Can you all hear me? Perfect. Super excited to be here. I was here just a little while ago for the MIT Hackathon. And I don't know if any of you guys participated in that, but so you're giving kind of a much more practical talk on the details of building agents. But because we're recruiting for the Innovation Lab, and I wanted to focus this first talk on Fetch AI, on kind of what we're doing at Fetch and what the future is for Fetch, which is really focused on agentic systems and the whole ecosystem of how we're heading into this area where agents talk to agents. But I think I should start probably with a little bit about me and how I got here so that you can figure out if it's worth listening to me at all. So I built my first website in, I think, 1996. So I've been kind of doing the web thing for a bit. Abby found it very funny that back then we didn't even have CSS. Like, it was straight HTML only, and it was inline styles for everything. If you wanted to change the color of a button, that was like a 2-week process for that button to change across all the different spots on the entire site and still look the same, until you learned a few other tools like Perl, where you would then automate generating the HTML. It's funny because we're all the way back with things like Gatsby to generating static sites, and that's kind of the way we started all the way back in 96, 97. But we just got some cooler tools with CSS and CSS pre-processing and all those pieces. So I built my first website in 96. I was a kid with a full ride scholarship to college, but it didn't really feel very right to me, so I bought a motorcycle, started driving around the country. And then I ended up landing somewhere. I was driving a beer truck, and I got a computer at the house and found all these crazy, amazing individuals just sharing information online about how to build websites when no one even knew the internet existed. And so I just self-taught and ended up and then just went out on the street and started selling door to door, selling websites to people who didn't know the internet was a thing. They're like, I can print some flyers. What are you talking about? Why would I need a website? And so kind of just went out and started selling websites, building websites for local businesses in the Metro Detroit area, and then turned that into a gig in marketing, which I then turned into an IT manager and spent my whole career half in marketing and half in IT and software engineering. And then turned that into an executive within 5 or 6 years at a company where we grew it from $3 million a year in revenue to $50 million a year in annual revenue within 4 years, selling handles, knobs, and hinges. So, like, not the most exciting thing in the world, but really got me my shot to be able to prove myself in the market. And then I've just always been pursuing the cutting edge of web development. And then through with the crazy things I've done, I managed beauty products. I sold beauty products for 6 years as a VP of marketing and e-commerce for the last independent nationwide distributor of beauty products, because they have huge consolidation and monopolization of that whole world for all the Revlons, and these people bought everything up. And so the very last independent distributor, we helped sell their products across the nation, and we manufactured and distributed all our own products, primarily in the nail category, but also in salons and estheticians and all that business. So very kind of cool and exciting. Different kinds of conferences than we have with AI. Like, the beauty conferences are like out of this world. Everything's top notch, everything's dialed in and beautiful and fun and champagne glasses. The AI and search conferences I've been involved with, a little drier, not quite as exciting. And I mean, the people are cool, but a beauty conference is a beauty conference. That's just something else. So how I got here is, as I went through this process, the last company I worked for was a company called Yellow Heart Ticketing. So it was a blockchain ticketing application. It was the only utility-first wallet that has ever existed, and still there are no utility wallets. They just are a view on what you have on your wallet in the blockchain. But we had a full media player. If you bought a ticket through us, we would send you a 4K video of the show the next day, and that would show up in your wallet, and you could play it, and you create a music collection of your favorite artists, et cetera. It was pretty exciting. Problem is, big, huge monopoly in that world with Ticketmaster. Didn't work out, ran out of money. I think right when FTX happened is when we were raising money. So that was like, I had this amazing meeting with the Comcast investment arm, and my daughter and I were out in Vegas, and she's listening to it, and she's like, man, Dad, you sounded smart. And I was like, oh man, it was great, they loved me. And then I went downstairs and played my first slot machine, won $4,000, so that happened. And then the next day, FTX happened, and we never got a call back ever again. So that ended that company. And so I just went out wandering for a little bit, and then I found FlockX, which is my full-time position, and we help you find your flock using technology to solve the epidemic of loneliness. And the sister company, or really the same founder, is the CEO and founder of Fetch AI, and that's Humayun Sheikh. Humayun Sheikh was the first investor in DeepMind. So he's going to respond. Everything that's in generative AI right now all comes from this original group that Humayun put together. And so just straight lucky that I got to land in this group of really intelligent, kind of future-thinking humans, and in particularly Humayun. So in this last year, we've got this word agent come up, and it's one of those buzzwords that's not real well defined. But Humayun was building the agentverse 6 years ago, before any of these people got this idea of the word agent and autonomous AI agents and them operating, for you or even any of this kind of generation stuff. And so as I started getting more involved in Fetch, started to really figure out what they're doing that was even the next level from where we are at now, is what this presentation is focused on, is AI agents, agent ecosystems, right? So if we give some kind of decent definition to agents, I would say kind of the most basic is some sort of AI-powered software installation that can operate independently to achieve goals, tasks, et cetera. But the key to the next layer, and everyone's focused on these kind of agents right now, everyone's got an agent framework, you've got Copilot, you've got whatever, GPT actions. These things are really starting to look like an agent world where it's an autonomous thing. OpenAI just released their scheduled tasks, which is about the closest thing to agents there, where you can say, I want to schedule this thing to go out and conduct this activity at given times of the day. It's funny because we had cron jobs in 1978, I think, but it's just cron jobs again, but telling your agent when to go do something. But the next kind of phase of this entire world is agents talking to agents and collaborating with each other to accomplish goals. So at FlockX, our mission is solving the epidemic of loneliness through technology, and we have an AI sidekick that looks out for your best interest. At FlockX, it's building the whole ecosystem for agents to communicate with agents to accomplish larger goals. So our AI sidekick would do things like, because it knows about you and you've had conversations with it, and it knows that my dog's name is Oslo and he's a Norwegian elk hound, you can't take him warm places because he'll get depressed. His whole world is about how cold is it, and the colder it gets, the happier he gets because he's a Norwegian elk hound. So it just knows these things about me. It knows my girlfriend doesn't like seafood, so it'll never try to send me on a date to a seafood restaurant. And so now my AI sidekick, by registering and finding other agents on the agentverse that Fetch AI produces, can have questions answered or get actions taken from agents in the wild. So where this is a little different than what we're seeing with, if you're familiar with LangChain or LangGraph or some of these other agentic frameworks, and they talk about multi-agent systems, they're talking about multi-agent systems that are all under your control. So it looks more like an internal dialogue. So you imagine you got the devil and angel on your shoulder, and this one's saying, hey, no, you got to go out tonight. And this one's saying, no, you got to test tomorrow. That's what these multi-agent systems are that are like popular in the media right now, is a request comes in and it's passing it around these identities that may be using different LLMs or the same LLM, but they've got different system prompts. And so they're collaborating internally. Kind of easy to do, like let's say it's easy, but it's easier to do than to communicate with an agent that you have no control over and then negotiate some sort of outcome, or even just discover if it's the right agent, it's the right AI at the right time who can fulfill the request or the need that you have. So that's what I'm going to focus on here, is how is Fetch AI laying the groundwork for the future on how agents in the wild can discover each other and communicate with each other and achieve goals together. So it really boils down to communication protocols, and there's not really anybody other than Fetch that's putting this in place, and we already have the frameworks in place, and they're available. There's no one really even having this conversation yet. And that's why I want to present it here, because we're recruiting, and I want you to have a feeling for how on the bleeding edge that fetch is, and really how we're not really predicting the future, but we're following the logical conclusion of what is the next step. So it starts with these communication protocols that allow you to kind of talk back and forth between these agents. And they need to do a thing that we've learned to do since we were young, that all the humans around us have taught us to do, which is have a directed graph conversation between us. We walk up to our friend, we introduce ourselves, we have some sort of interest identification. Oh, what are you doing today? What am I doing today? Is it worth us having a conversation? And then we move on to, oh, like you're going to the Irish pub? Like, I want to go to the Irish pub too. We negotiate accomplishing that, and that's a directed graph conversation. That's moving from a node to a node along a path, and then ending that conversation with a goodbye, I'll meet you later, or whatever. So that's not inherently built in to how LLMs work. So if you take ChatGPT on two phones and put it on voice mode and stick them next to each other, they will talk back and forth to each other until madness ensues. They will never stop because there's no guardrails around that conversation. So the foundation of this interaction between agents is about communication protocols and how we can design them for given domains to achieve these outcomes without human in the loop, so that they can operate autonomously, have those conversations. Another piece of that is, how do we build that trust so that they can collaborate? Have you contacted the right AI? And so that initial step of that directed graph conversation, maybe, do you provide this capability? Oh, yes, I provide this capability. What's your history of delivering on the promises that you've made? Which is probably the best use of blockchain that there could be, would be like a reputation system. Blockchain is inherently a one-way path, and the information in the past can't be changed. It's okay for commerce and all the coins and all that stuff, but in the reality of how we exchange money, we need not just one-way transactions, right? We need refunds and all sorts of different things involved in that. But what we can do is build agents that have historical reputations that can be proof that they've been able to accomplish the capabilities they advertise. And so that's kind of the trust part, is my agent has a directed graph associated with it that says I need to investigate the AI that I found, can do the thing that I need done, be able to look at its history, its reputation, and then also ask it the appropriate questions of, is this kind of data I'm going to send you, is that appropriate to achieve the outcome? And that's where we come into building these communication protocols and having trust as the first step in that process. So kind of start to talk about the evolution of these systems, and I went into a little bit before. We're in the early AI systems right now. Kind of step past all the machine learning and all that stuff that's really led us to this point, because what people are calling AI systems now is really focused on these agents and really how LLMs interact with those agents. But the next step is these open ecosystems, and particularly the only current open ecosystem is Agentverse. There's a couple more popping up right now. Agent.ai is just a new one I found just this week. Is one of the founders of HubSpot and the CTO of HubSpot, that's his project that he's working on. Then you've got this Copilot thing that's just come out, where you can now build agents into Copilot, and they'll get distributed into the Copilot ecosystem. So those are closed systems. The Agentverse is open source, decentralized, open ecosystems. It's the only thing of its kind. And then we're building tools right now that will allow you to publish to every one of these ecosystems. So now that becomes just like when you're trying to do SEO for a website, you have maybe Ahref is one of the places, but there's been lots of places over time where you analyze your website, then you publish it out to Google, publish it out to Yahoo. It's kind of only Google now, but back in my day, there was like 300 search engines that you would publish to. And so now that's the world we're in right now with the Agentverse. So the kind of fetch approach is really focused on openness and having the ability to design your own protocols that are domain specific, and then us providing a set of those protocols, and those protocols being a directed graph design. So we have a framework that's open source called Dialogues, and it just allows you to design that graph. So I'll say these are the stages of the conversation, and for each stage, I'm going to detect if I'm ready to move to the next stage, and I'm going to have a separate, when it comes right down into code, I'm going to have a separate handler that is handling each stage of that conversation. And then everything behind it, you use whatever framework you want. So it could be LangChain, LangGraph, could be Haystack, whichever your chosen framework is, this will plug into, and so that your independent agent that you control, wherever you host it, wherever we have hosting on Agentverse too, but you can host your agent anywhere, and then it will connect and register on Agentverse, and now say, hey, I speak this protocol, what other agents speak that protocol, and now what of those agents are relevant. I want to find, I'm doing a research project on what college I want to go to. You guys are already here, but it's probably recent in your memory, figuring out which school you're going to go to. Maybe your AI sidekick from FlockX goes out and searches for the community AI that represents Michigan State, the community AI that represents Stanford, and the AI that represents MIT. It can go and ask each of those specific questions relevant to you, because the sidekick that represents you has your preference graph. It knows about you. It knows your preferred material sciences. It knows that this is your history of learning and what you learn best at and what environment is going to be best for you. Rather than you pouring through all these websites, it can go and talk to those other AIs that represent them, or independently do the research on their websites, gather back a report that's customized and personalized to you, that speaks in the way you speak, and now you're talking to your sidekick and it's independently doing that research for you to find the best and right school. Maybe it's the school that has the best scholarships. Maybe it's the school where the most graduates in your field got the best jobs, but it knows your kind of preferences and your goals, and so it can do that research in the context of you. So completely personalized, research and search that's never existed before. I mean, so far it's been us typing a bunch of search terms into Google, reading a bunch of websites, kind of collecting that all in our own heads, maybe copying and pasting a bunch of stuff into a document to collect our research. That can all be automated, so you can spend more time on the thing you love, whether it's your hobbies or pursuing, your craftsmanship in whatever goal you're trying to achieve. That is the thing that's kind of here right now that you can weave together on your own, and the tool set and the ecosystems for that are showing up. So in this kind of concept of agents and Agentverse, it all starts with search and discovery. So at FlockX, we build this AI sidekick. So that's kind of put everything in the context of that. That sidekick represents me. So the first thing it's going to do is go out and search into these ecosystems for agents that are going to be able to fulfill my goal. If that's a research on colleges, it's going to search out all the colleges that match, whether it's my budget, my potential scholarship opportunities, the appropriate curriculums, and then be able to find and start the conversation. And then what I was talking about with that validation and handshake here is the idea that as I find these other agents that are independent, not controlled by me, that I can start to have conversations to see if it's the right agent to be talking to, right? Validating that the request I'm trying to achieve can be fulfilled by that other agent in the wild, and then deciding to move forward in that conversation. And then that all ends with now being able to pass the right formatted messages, so they won't just be a text message like you're doing with with a LLM. Like if you're in ChatGPT and you're just having a conversation back and forth, this becomes a more formalized type of message passing where you're going to have your query or the things you're trying to achieve, the history of your conversation, but you may have a shared data structure that you're filling out together. These two agents are filling out a shared data structure together to achieve that final outcome. So that shared data structure, maybe if it's a research project, is filling, hey, I need these items or these bullet points to be known at the end of this conversation. And so the two work together to fill in that shared data structure. If it's to take action, say schedule something on a calendar, book concert tickets, then that shared data structure, maybe here's the receipt number, here's the link out, here's how you're going to receive your QR code to get through the door. That could be the pieces that are filled in that shared data structure, while the kind of query or message passing will be the conversation that's happening, and agent on either side is extracting details and data from there and filling in the data structure together. So I kind of went through this pretty thoroughly already, but these shared conversation graphs is, and maybe I skipped a little ahead in the last one. This is really what it's about, is that directed graph conversation and that dynamic representation where the two agents are working together to fill out a data structure. Right now it's all JSON schema, and you just include that in your request, and now the two agents are filling it out. And that then becomes transparent to each side so that you can review the quality of your agent that's representing you. You can go back and review the conversations so that you can then improve that over time. And who's ever operating, say it's the community AI that represents MIT, the people, and probably end up being students who are managing and operating that community AI, can look at all the previous conversations and judge the quality. So now you can go back into a reinforcement learning scenario by saying these were great answers, these were bad answers, this was exactly the right answer, and now run that back through a reinforcement learning that's going to improve the core models behind that agent over time. So yeah, real world applications is really where it boils down to. So one of the things we call them community AIs at FlockX that we're building that allow an individual who's running a community, basically the community AI becomes their community co-founder. And so you can manage a knowledge or a corpus of documents, a calendar, et cetera, that is what your community AI needs to know to answer questions to the community. And then those community AIs could be registered out on Agentverse so they can be discovered by, say, people's personal sidekicks or other agents to answer questions. Kind of where LLMs and agents are working really well right now is not the giant, I stripped in all the data on the internet and now I can answer questions about everything in the universe. Those are not proving to be the best answers. A lot of hallucinations, a lot of like making stuff up. But when it's kind of boiled down to a core domain of very high quality specific information, then LLMs get a lot better at producing meaningful answers for us that matter. And so where we start to get into real world applications is, say you've got a legal agent that knows everything about the state of Michigan and all our laws there, that can become a great resource for, say, an attorney or the agent working for the attorney, getting answers about given cases. In healthcare, the same thing. If you have given domains like cardiology or neurology, you have an AI agent that knows everything about neurology or some subset of that. It can answer questions in a more accurate and more thorough way that are more likely to deliver positive outcomes. And then education, the same kind of thing. You take domains of knowledge and have an agent that represents just that. Now you can have, say, my personal agent go out and talk to each of these and form better answers because it's getting higher quality answers from each one of those agents on their specific subset of information. So if you imagine you're doing a large project of any kind, forget agents altogether. As a human, you're going out in the world and you're going to build something cool. And it's going to be multifaceted. So if I'm just going to build a convenience store, I need an expert on retail layout. I need an expert on what does this community, they prefer Coca-Cola, they prefer Pepsi. These are different domains, and I need each one of those experts to know their business the best. What are the business licenses I need to have? I need an attorney who's going to tell me how to set up my business so that I have proper, tax categorization and those things. So we already are working in this world where experts in a given subject, as a person who's building a project, I'm talking to each of those experts to get the best possible answer in each domain in order to make the best decisions for me and for whatever is my particular project. And so that's where I see the agent-to-agent communication working the best as well. It's no different than what we're already doing as humans. We're kind of taking the processes we already have and putting them onto this agentic world. So, challenges and future directions. Aligning these diverse agents, that's going to be a key factor. That's going to be part of that is going to be building standardized communication protocols. We've open sourced the whole framework, so it's all about the entire world contributing domain-specific conversation protocols. You have different protocols if you're talking about something medical, where you have to get this initial information. You need a medical history that all start that conversation. So you can't get answers until you have enough knowledge and information to determine an answer. And that's the same in lots of domains. You can't build a certain kind of building if you don't know something about the environment there, humidity, moisture, changes the materials you use, those kind of things. So having specific protocols for each one of these domains is going to be valuable and important. And ensuring that knowledge quality is like in each one of these agents, being able to have logs of how they're interacting and the answers they're providing so that you can then train them and get better at them over time. You know, it's the standard feedback loop. Yes, good answer, bad answer, good answer, bad answer. And then again, the trust and transparency, which is just making sure there's a credibility, there's a history, there's a reputation history, et cetera. So I ran through that fast. And so we open it up to questions. And what anybody thinks about the age of agents operating autonomously and independently amongst each other.
I guess we'll just do this informally. If you have a question, raise your hand, and if you're sitting in the back, I'll bring the mic to you. If you're sitting in the front, you can just like say your question.
I know you guys are more curious than that. Yeah, what do you got?
Okay. When I first started studying AI, I think the idea of an AI agent that, you know, could act as a co-pilot, no pun intended, was always sort of a vision of mine. So I'm really glad to see you bringing this up and trying to make it happen. I'm really inspired by that. But I was really curious about that trust and verification mechanism you were talking about earlier, about, you know, deciding if an agent is good at providing a certain kind of answer within that network. How would you like decide how trustworthy that agent is?
Yeah, so initially, and we're just in the entry level building the reputation system, but the first part is to be able to reach out and say, what other agents have you done business with or had communication with? Also being able to then reach out to those agents and say, how was your interaction with that agent? That's the more complicated version. Initially, it's just straight up asking, can you do this thing? And then running and trying to get it to do a thing, and then recording in your agent's history the success you had with asking that agent to commit and transact on the capability it advertised. So internal memory starts first, then reputation system, and then when we go from there, it'll get way more complicated on, you may have an open source project that represents a certain type of agent, and you can run it on your laptop and have it on Agentverse able to do things. And then somebody else might have it running in a data center. And you might have a different cost because you just run it in your dorm room on Saturday nights, and that's the only time it's open, right? So its availability is lower. So, and it's not going to do, because it's run on your laptop, it's not going to get the answers as quickly. And so you'll advertise, this is my quality of service, or in our corporate world, we say SLAs, our service level agreement. And so I'll have a cheaper price because it's run on my laptop and I only work on Saturdays. But this guy running the exact same project in a data center may be saying, like, I have, 20 millisecond response times. I produce answers, 24 hours a day. I can run 100,000 concurrent answers at one time, but it's still the same exact open source project. They're hosting it differently, and so they're going to charge more for that low response time, and that will be advertised in their capabilities. So that's kind of a few steps away from where we're at right now, but it's kind of a knowable future because it's like, you can kind of, once you start down a path, you know what the other side of the chessboard is. Like, you can only go one way. And so that's kind of a natural progression of that step.
Okay. Thanks so much.
What exactly do you mean by communication protocols for the agent? It's like...
So it's the designing of a directed graph conversation. There's a good example that I have is one of the first things I did in the Agentverse as a project was basically a simulation example as I was trying to do research for FlockX and how we were attempting to help people find a third place. If you know what a third place is from a sociology concept, first place is home, second place is work, third place would be that socialization place, your bowling league, your church. Historically, it's been church for a lot of people, but whatever is your socialization, that's your third place where you hang out and meet other people who are into the same shared interests as you. So what I did is I created 6 community members, and basically I just I've got a long time in marketing, so creating marketing personas is a thing I know a lot about. I just went into ChatGPT and I said, produce 6 marketing personas in great detail. Give them educational history, give them job history, give them income history, and then what their interests are. And I want 3 of those to be senior community members, and I want 3 of those to be like young, new community members who are trying to find their place. And then I just set them all to talking. So in order to accomplish that, I needed to put together, here's how the conversation starts. It starts with discovery, so looking for someone who's in need. So the older community members would look through the 3 younger members, find one to help, and start a conversation. So that was discovery, is that first step of that directed graph. Then the next node on it is interest identification. So the 2 would talk back, and so in that part it was cyclical until they achieved, and each 10 I'm doing like an intent or a analysis that says I've achieved my goal or I haven't for each stage in that directed graph. And so they talk back and forth until they say, okay, you're into baseball, little league, this is what I know about your interests. And so we've identified that we both are into baseball and we can help each other there. Then they move next to the, okay, now that I know you're into baseball and little league, the next stage in the directed graph would be 3rd place options. So they're like looking around for, okay, in my community, I know that this John Ballpark Zoo has baseball fields and they have Little League there. Then there's also this other place over at Richmond Park, and they also have a different Little League over there. And then they would have that conversation about the options, and the stage would be, okay, have we figured out which one is the right one? And so then they would move on to the next stage, which would be finalizing and meeting at one of those places to discuss further. So that's the communication protocol. It's just that directed graph with stages. When it's a simple one, right? It's just a straightforward node, 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 with the edges being straight through, but having some cycles. Much more complicated directed graphs that we have, and actually it would be interesting, I just showed this right before. Let's see if we got, if you guys have ever, anybody familiar with LangGraph and LangGraph Studio? So we have some pretty complicated LangGraph graphs in LangGraph Studio, and this is what our graphs start to look like when you get, like a much more complicated graph where you're navigating across all these conditional edges, and each node in that graph is a decision point that then is determining the routing to the next compute node. So whereas this one is more functional in cognition, it is the same concept for the communication protocol. So the way we see this happening in the future is you've got a cognition graph behind this agent and a cognition graph behind this agent, and that would be this type of graph. And then in between them, you have your communication graph. And so they're both collaborating across this communication graph with a single point of contact to the communication graph and all their cognition hidden behind that. So it essentially becomes a natural language API between them that's going from stage to stage in the conversation so that it doesn't just talk forever and not accomplish its goal, right? And that's really the main point of that directed graph conversation, is just put guardrails around what we do naturally because we've developed it over thousands and thousands of years of how we interact with each other.
Okay, thank you.
Hi, thank you so much for your talk today. I have 2 questions. So the first is, how do you evaluate if the outputs of the agents is actually correct? Because the way that I see agents now is that very often they hallucinate or they give a certain weird output.
Yeah, so we're doing that in a few different ways. One of that is the standard old human feedback loop, where we're going through historical conversations and we're using a tool called LangSmith. Like, we're pretty into that whole LangChain, LangGraph, LangSmith ecosystem and tool chain. And so LangSmith lets you walk through every single conversation and put in feedback on each of those outcomes. But then we're also using reflection graphs that are actually taking the answers and then doing multiple turns of evaluating the quality of those answers using different models. So we'll essentially like spray that answer out to 6 different models and ask each model to give us a quality score on that answer based on the goal that was the original goal, and then compare them back to each other and use some sort of unionization of those quality scores to give it a like ultimate quality score. And that's how we're doing a lot of the automation of quality management.
Right, that's cool. My second question is, since you're working with a lot of agents, which means different types of models, have you ever considered fine-tuning a specific model for each individual agent? And if you did, how was your, do you have any insights for that?
So in each one of our agents, we could use 12, 15 different models. So while we do some fine-tuning, it will be on a specific decision-making node. It's not trying to train an LLM to answer all the questions. It's about, like I showed that graph, which is our cognition graph, is that each one of those nodes inside there is likely using a completely different model. Anthropic for tool selection every time. There's nothing that compares to Anthropic for bringing a request and doing tool selection. Like, it smokes everybody else. When it comes to tone and personality, OpenAI, as every single model that keeps getting better, we get better tone and personality. So how our graph works is a question comes in and it's got message history and it's got memory, because through all our conversations we're pulling out facts that say my dog's name is Oslo, I ride a bike, these kind of things. We include that fact table in our system prompt as well. And so as we're going through that process, like the node we have right now, it's a supervisor pattern, and that initial node just says, okay, what's the goal and which one of these other nodes can fulfill the goal best? And each one of those has its own vector store, has its own data. One of them's like to find events locally. One of them's like, how do I organize packing for travel because I'm going to Alaska? And then at the end, we always send everything out through a personality node that then rephrases everything to match the tone of the user that's conversing with it. So that lets us get very non-emotional, more scientific answers throughout the graph, but then pass it out through personality and tone so that now it becomes talking to you the way you want to be talked to. Or it's millennial kind of speak with emojis and feel good stuff, or if it's old Gen X, like be tough and drink from a water hose, right? Like it's putting the tone for me in a way that I can understand, which is how real communication works. Like, even if you guys are just having a conversation, I'm going to listen to how you're speaking in order to know how to speak back to you in a way that you'll get what I'm saying.
Also, just a side note, the questions do not have to be technical. They can be literally anything you want. You can ask Mark about the beauty conferences he's been to.
Yeah, or how I bullshit my way into just about every job until I had a resume behind me.
So what are the advantages of using a special platform to train or fine-tune a language model compared to just writing a Python code file and submitting it for execution on a computing cluster? Because personally, whenever I needed to fine-tune an LLM, I just did so directly. But how could it have been better if I used some platform?
Yeah, so it really boils down to frameworks exist for a reason, right? Sometimes when you're deep into a particular tech, you can do a lot of things faster because you understand all the details. But as any of these technologies progress, it's like we have content management systems for building websites, right? You could just build all the HTML pages because you're good at it, and maybe you even know how to write some great Python that'll generate all the HTML pages. But ultimately, you can't do everything yourself, and so you need to be able to provide your knowledge and your abilities out to other people through automation. And so that's where frameworks come in. And that's essentially what you're talking about. How I can, I'm really good at like training these things on my own, but now when you're in an organization and in a team, you'll be the only one who's good at that, but you need them to be able to do things on their own, and you're gonna pick most of the factors for them because they don't know as much as you do. And so you're then gonna give them a tool, which is that framework, so that they can now do some of the work that they can do, that they know how to do, but they can't do the work you know how to do. And so you build these frameworks that are simpler, and they have a bunch of choices made for them, but it's about offloading your labor in order to achieve larger goals. And that's no different in any part of the world. Like, yeah, maybe I know how to make my own gasoline from oil, but like offloading it onto a much more complicated infrastructure that also distributes it to the gas stations and all around the world is essentially automation of something specialized. And so it's all about distribution of labor and making things easier for people who don't have the same level of technical skills that you have. And then building automated pipelines, like, is how the world works.
Maybe from a more economic standpoint, but if we see labor as being something that typically is not something that you can move across borders, right? Whereas you can trade goods across borders. How do you envision the use of agents to, I guess, transmit labor? How do you think that in the long run will affect the labor market, right? Will we have specialists from countries with possibly lower cost of living, lower income? Will that reduce demand for higher skilled jobs in the United States?
So I'm an extremely radical person when it gets into these subject matters. I don't think borders should exist in any way, shape, or form. Like, I'm pretty radical. I'm a kid who grew up on the street, like spent a lot of time homeless as a kid. Like, I have a different view on how the world should work, even though I've played in the game that the world has now. I think there's gonna be dramatic change, but we already live in a post-scarcity society, but we pretend to have scarcity. And so I think in your guys' careers, I'm gonna be out. Like, I'm gonna be out on a beach somewhere, I'm gonna be retired. You guys gotta figure all this stuff out. I'm sorry we left you the pile of problems that we left. But like, I think every single human is inherently good and wants to support the human next to him. And so I think these problems are gonna get solved, I mean, it's by your generation, but by not worrying too much about the problem, by just trying to focus on doing things that have deliver more than you need, that ultimately lifts everybody up. So while there's going to be these, navigating this idea of, oh, well, people make less over here, and then now if companies can hire them, then it's going to affect me here, and I have a higher cost of living, so that's kind of going to burn my labor, my career here. That's going to level out, but it's going to level out through hopefully not too violent of a moment. But I think if we build the right automations into the world, my whole career is built on open source software. That's why Agentverse is so fascinating to me, and why I really wanted to work with Humayan, is because he already made all the money. Like, this guy's made the money. And now he's just giving things away so that he can create a democratized access to the new level of automation in the world, which is this AI agents operating for us. And so I'm heading down that direction of how can we help everyone at the same time by giving away as much of what I have, my knowledge, my code, as I possibly can, because I make enough. And I'm not trying to get a mansion or fancy cars. I have my motorcycle and my dog. That's all I need, and some cool computers and VR stuff. So yeah, I know that's not a very practical answer, because it's a hard, fantastic question. It's a hard question to answer. And that's a prediction that's going to be chaotic in the next 20 years. But good luck. I'll do as much as I can through my career to produce as much that helps everybody get to where they're going.
Okay, we have a couple more questions from people, but it is 2. So for the sake of time, would you like to move into your next lecture, or would you like to just let the Q&A keep flowing?
We can let the Q&A keep flowing.
Hi, it's me again. I just wanted to ask,